Count to 10 on your fingers. That's how you count almost everything. Money, distance, weight. The whole modern world runs on tens, on 10 digits, on the number you were born wearing on your hands. Now look at the clock. 60 seconds in a minute, 60 minutes in an hour, not 100, not 10, 60. And then the circle on your compass, 360 degrees. Where did that come from? Here's the strange part. Everything else got upgraded. We threw out the old measures and rebuilt them in clean, rational tens. But time is still counting in a system from the Bronze Age. A system that is not base 10 at all. It's base 60. Somewhere in the deep past, somebody decided that 60 was the right number to slice time into, and we have never once changed our minds. You check it 40 times a day. It sits on your wrist and glows on your phone, and it is running on arithmetic invented by people who wrote on wet clay 4,000 years ago. So why 60? And why, of everything we modernized, did we never touch this? This is the story of the oldest piece of math you use every single day. Let's sit with how odd this really is. We are obsessed with tidy tens. There are 100 cents in a dollar, 100 centimeters in a meter, 1,000 grams in a kilogram. When the French Revolution came, they even tried to decimalize time itself. 10 hours in a day, 100 minutes in an hour, 100 seconds in a minute. Clean, logical, rational. It failed almost instantly. The clocks were beautiful and nobody wanted them. Within a couple of years, the experiment was dead and France went back to 60. Think about that. A nation confident enough to rename the months, reset the calendar, and behead a king looked at the 60-second minute and blinked. The old time was simply too deep to dig out. So this number 60 is not a leftover nobody noticed. It survived a direct attack. It beat the most rational revolution in history, which means it must be doing something that plain, sensible 10 cannot do. To understand what, you have to stop thinking like someone with a calculator and start thinking like someone who has no decimal point at all. You have to go back to the people who first carved numbers into clay on a hot plain between two rivers. The trail leads to Mesopotamia, the land between the Tigris and the Euphrates, in what is now Iraq. Here, more than 4,000 years ago, the Sumerians and then the Babylonians built the first cities, the first writing, and the first real mathematics. And their math did not work like yours. You count in tens, almost certainly because you have 10 fingers. It feels natural, even inevitable, but the Babylonians counted in 60s. Sexagesimal, we call it. To them, 60 was the round, comfortable number that 10 is to you. They wrote it by pressing a reed stylus into wet clay, making little wedge-shaped marks we call cuneiform. A small mark for ones, a larger mark for tens, grouped and stacked, all building up towards 60. Tens of thousands of these tablets survive, dug out of the desert. Receipts, school exercises, star charts, and tables of numbers a student practiced until the clay went hard. Now here is the question that hangs over all of it. 10 makes obvious sense. You can see it on your hands. But why on earth would anyone build their entire civilization's arithmetic around 60? It sounds clumsy. It sounds enormous. And yet, once you understand what 60 can do, you start to suspect those clay tablet scribes were smarter than the system you use today. Here is the secret, and it is pure, elegant mathematics. Take the number 10. Ask what divides into it cleanly with no fraction left over. Just two numbers do, 2 and 5. That's all. Try to split 10 into 3 equal parts and you get 3.333 running on forever. Split it into 4, into 6, and it breaks. 10 is brittle. Now take 60. 60 divides cleanly by 2. by 3, by 4, by 5, by 6, by 10, by 12, by 15, by 20, and by 30. 10 different ways to cut it without a mess. This is the whole answer, and it is beautiful. In a world with no decimal point, no calculators, no easy way to write a fraction, you desperately want numbers that break apart neatly. 60 is the smallest number that splits into halves, thirds, quarters, fifths, and sixths, all at once, every time with nothing left over. So when a Babylonian merchant divided a measure of grain among 3 men or 4 or 6, the math just worked. No remainders, no fractions to fight. 60 was not clumsy. 60 was the most flexible number a person could carry in their head. And once you have built your whole world on a number that divides that beautifully, you start using it for everything, including the one thing humans most desperately needed to cut into pieces, the day. Because here is where the number leaves the clay tablet and climbs into the heavens. The Babylonians were relentless watchers of the sky. They tracked the sun, the moon, and the planets with astonishing care, recording where each one sat against the stars, night after night, for centuries. And when they measured the path the sun traced across the sky over a year, they divided that great circle the way they divided everything else, using their beloved 60. They cut the circle into 360 parts, 60 times 6. That is where the 360 degrees in a circle comes from, the same number on the compass in your phone right now. It is Babylonian. But the day needed slicing too, and here a second civilization enters the story, the Egyptians. They looked at the night and picked out a sequence of stars they called decans, rising in turn through the darkness, and by those stars they split the night into 12 parts. Then they matched it with 12 for the day. 12 and 12. And there is your 24-hour day, born not from 60, but from Egyptian stars. 2 different peoples, 2 different obsessions with the sky, quietly handing pieces of the clock to each other across the ancient world. The hours were Egyptian, but the moment anyone tried to slice an hour into something finer, they reached, once again, for Babylon. For most of human history, this is where time simply stopped. You had the hour, and below the hour, nothing. There was no minute. There was no second. Nobody needed them, and nobody could measure them. A sundial gives you the hour, roughly. A water clock dripping in a temple gives you a little more. But the idea of carving an hour into 60 tiny equal slices was, for thousands of years, purely theoretical. It lived in the minds of astronomers, the heirs of Babylon, doing their calculations the only way they knew how. So when they needed to divide the hour, they did the natural thing. They split it into 60 parts. In Latin, this was the pars minuta prima, the first small part. And when 60 still was not fine enough, they split that small part into 60 again, the pars minuta secunda, the second small part. Listen to those words again. The first small part, the second small part. That is exactly where the words come from. Your minute is literally the minute, the tiny division of the hour. Your second is the second division, the cut made after the first. You say these words every day and never hear them. But every time you check the seconds ticking by, you are speaking Latin shorthand for a piece of Babylonian 60. There was just one problem. For most of history, these minutes and seconds existed only on paper. No clock on earth could actually keep them. That changed in medieval Europe, in the cold stone towers of monasteries and cathedrals. Monks lived by a strict schedule of prayer, and they needed something to wake them and summon them, reliably, through the night. Out of that need came one of the great inventions of the age, the mechanical clock, driven by falling weights and a clever swinging mechanism that ticked time out in even beats. The first of these clocks had no minute hand at all. They just struck the hour on a bell. The word clock itself comes from the word for bell. But the machine had a hidden gift. Because it ran on gears, and gears can be cut to any ratio you like, it could finally divide the hour evenly into exactly 60 equal mechanical parts. The minute stopped being a line in an astronomer's notebook and became a thing you could hear. A tick, then a tick small enough to be a second. The ancient Babylonian fraction had been poured into brass and iron and set ticking in a tower over the town square. And once a whole town could hear the same minute, everything began to change. Bells rang the start of work and the end of it. Time stopped belonging to the sun and started belonging to the machine. But these clocks still disagreed, town to town, by whole minutes. To truly lock the world onto Babylonian time, you needed one more force, something that could not tolerate a single town keeping its own hour. You needed speed. The year is the 1800s, and a new machine is tearing across the landscape, the railway. And the railway has a problem that will, without anyone intending it, weld Babylonian math onto the entire planet. For all of history, every town set its own time by its own noon, when the sun stood highest. So the clocks in one city ran minutes ahead of the next town down the line. For a man on a horse, this never mattered. But put him on a train moving 60 miles an hour, and suddenly it matters enormously. A timetable is useless if every station counts the minutes differently. Trains on the same track, running on different times, do not just confuse passengers, they collide. So the railways did something no empire had ever fully managed. They forced everyone onto one clock. Standard time. The same minute, the same second, ticking in perfect agreement across whole countries, and soon across oceans, all of it carved into the global timetables of trade. And notice what they standardized. Not a clean, rational decimal time. They locked the world permanently onto the 60-second minute. The Babylonian fraction, now humming through telegraph wires and train schedules, became the synchronized heartbeat of the modern age. This is the moment it became truly unkillable. Once every bank, every railway, and every navy on Earth agreed to the same second, no one could ever change it again. To touch the definition of a minute now would mean rewriting every schedule, every contract, every machine, all at once. The cost of switching had become infinite. And so the strangest thing happened. We kept it. Not because anyone chose 60, but because 4,000 years of momentum had made a Bronze Age fraction simply too heavy to lift out. The world did not keep Babylonian time on purpose. It kept it because, by the time anyone might have asked the question, it was already far too late. So here is where it leaves you. The next time you glance at your phone and watch the seconds tick, 60 of them, climbing to a minute, understand what you are actually looking at. You are looking at a Sumerian scribe pressing wedges into wet clay, choosing 60, because it broke so cleanly into pieces. You are looking at Egyptian priests counting stars to carve up the night. You are looking at a Latin phrase for the first small part, and a monk's iron bell, and a railway that could not let two towns disagree. None of them knew you. None of them planned for this, and not one single person in 4,000 years ever sat down and decided that you, today, should count your life in 60s. It was never chosen. It was only inherited, handed down across 40 centuries, until it became the most invisible math in the world. That is the quiet truth of the clock on your wrist. It feels like the most modern thing you own. And it is running, second by second, on arithmetic older than the pyramids that nobody alive ever agreed to keep. Which makes you wonder, How much of your supposedly modern life is really just an ancient idea, still running, long after everyone forgot to ask why? That's what this channel is for. I'm glad you're here, and I'll see you next time.